Raji, as we fondly call him, for this opportunity to be present here. I believe, and I'm really talking to the students here and no one else, that you are fortunate to be part of this enterprise. I call it an enterprise. It's a unique institution modeled after the vision, the grand vision that Raji has about what education should be. And you are in many ways participants in that experiment that he has initiated. It is really his drive, his vision, his effort, his wisdom that has created this whole enterprise. And I have no doubts that this place will very soon be recognized all over the world. I see all the necessary features already being put in place to put this on the world map. So I am fortunate also to be part of this experiment. I also want to thank Rajiv Shori, my friend and fellow Stephanian, who is the right man to fulfill Raji's vision. So I think we will see very soon the flowering of the great institution. Let me at the outset clarify that by no stretch of imagination am I a historian. So this is not coming to you from the perspective of a historian. So do not look for a professional historian's viewpoint. There are many reasons why I have created this lecture. One of them is to balance slightly this Eurocentric view of how mathematics developed in the world. When I grew up as a school child, I was dimly aware that there were many things India had done in mathematics and also the other sciences, but only dimly aware. I was told there were inventions in mathematics that made Newton the greatest mind ever. I wasn't aware that there were things that had been done in India much before Newton on the same lines. And that brings me to the second reason. So I don't just want to balance this historical Eurocentric view of the history of mathematics. It isn't just balancing. I want you, young minds, to take pride in where our country has come from, what have been our traditions. How have we developed? What is our heritage? And you know, I don't want you to take pride for any chivalrous reason. No, I don't want you to say, "Hum bade mahan the," and then go back to bed. I want you to awaken yourself, to create that self-confidence, to create that desire to keep the flag aloft. That is what I want to do. That is my most important reason. And so I hope that if even a fraction of the things that I believe must go to the youth through this lecture get embedded in your minds, I will find I have been successful. And as you can see, I have titled my lecture as From the Indus Civilization to Srinivasa Ramanujan. It more or less covers the history of India. The Indus civilization is probably one of the oldest civilizations ever to have been developed, and it was developed very much in our land. And I start from there. So let's see what the Indus civilization was about. I'm sure many of you recognize this picture. You know, it is the great bath at Mohenjo-daro. It was a very sophisticated urban civilization. You know, it is an extensive civilization. It wasn't just Mohenjo-daro and Harappa. It spread over a large area and it was dotted with various places where it grew. And all urban. There is no rural situation to this civilization. It's purely brick-based urban civilization. So you can imagine in 3000 BC, you can see that all these structures over here, they're all made of brick. All this is made of baked clay brick. And I'll come to that and how how precise they were in their sophistication. But let me just move forward. That yellow region there, you see that? That's Mohenjo-daro, Harappa, that's Lothal in Gujarat. This entire yellow region is more than 1 million square kilometers. Why is it called the Indus civilization? Because you can see the Indus goes right through it. At one time it used to be called the Indus Valley civilization, but there isn't really a valley here. But that is the civilization. And it isn't just Kalibangan or Harappa or Mohenjo-daro or Lothal. It's actually dotted with lots of smaller towns and kasbahs, no villages. All over this region, all over this. And as I talk to you, more and more places are being discovered and more things are being discovered about this civilization. And look how old it was. 3,000 years before the time of Christ. That's how old this civilization was. To give you an idea of its sophistication, this is, Lothal was a port city. It's based on the sea. And they used to have extensive trade. There are enough seals discovered, enough excavations having taken place at Lothal in Gujarat. And I would urge all of you, at some point in your life, you must visit one of the Indus sites. Preferably some site like Lothal. Look at the degree of sophistication. That's how they used to work. That's how the seaport was. Ships used to dock here. This is based on an artist's imagination with inputs from archaeologists after they had excavated Lothal. So this is very, very accurate situation of Lothal. Some more pictures of other sites that have been excavated. This is Kalibangan. You can see one thing here. There's a lot of symmetry, straight lines, rectangular or square-like structures. You'll see this is a hallmark of the Indus civilization. You look at this brick here. See that? Do you think it is any different from the modern bricks that we have? Not at all. How many years ago was it? 5,000 years ago they used to make those bricks. Well, the degree of advancements in science and technology can be gauged from the highly evolved system of plumbing. I'm sure you've heard of the plumbing system. If you go look at their toilets, they are so sophisticated. And it wasn't just again at Mohenjo-daro or Harappa. No, it's through this entire 20 million square mile territory. The same degree of sophistication in technology. And you know, technology cannot happen unless there is some theory to back it up. Technology never happens in isolation. It goes hand in hand with the sciences. So if they could do all those sophisticated things, this sculpture that you see here, you know, the kind of smoothness, the precision that they have over here, you see these lines, how parallel they are. They can't happen unless you have precise technological tools. So they were extremely sophisticated. They were really well developed. And why do I say all this? Because mathematics also has something to do with that. Let's just go back to this brick that we found here. You know, all the bricks that you find there are in this proportion. 4:2:1. Completely standard proportion. 4:2:1. And I have spoken to civil engineers who tell me that this is the best proportion to bring strength to buildings which are based on brick. This is the best proportion. And this is uniform through that entire 20 million square mile territory. Now, I want you to ponder about this. You know, today, when I have to go buy a plug to fit in some socket at home, I could go purchase it from some electrical outlet. When I bring it home, I have trouble making it fit properly. I have great trouble. Either it's too tight or too loose. And here is this civilization, 5,000 years ago, creating bricks with a technology that would allow you to use the same proportions throughout that entire territory. There was no internet, there was no email, there was no airmail, there was nothing. How did they manage that? But they were extremely sophisticated. There was great degree of communication and standardization. One of the things is severely lacking in India, standardization in technological processes. So I want you to think about that, to take pride in this. And there's maths in here. They figured out this proportion. They also used a standard system of weights. And they always had weights based on these ratios that I've outlined over there for you. All of them. Here's one of the pictures of the weights that they used. Completely standard. You could actually take one weight, make it the unit, everything else would be an integral multiple or a fraction of that. So they certainly understood fractions very well. And if you understand fractions, then you will have to create sophisticated mathematics. If you start using fractions in your everyday life, then you'll have to start understanding sophistication in mathematics. Why do I keep saying you will have to do that, you will have to do that? Well, look at the shapes that they have. Geometrical shapes, hexahedra, barrels, cones, cylinders, all the standard shapes of geometry. All the standard shapes of three-dimensional geometry. And you can't just suddenly out of the blue decide I want these shapes because someone dreamt it up. Because these are the shapes that bring value and weight to a system of technology. So they didn't do this out of isolation. They were working towards a purpose based on some deep knowledge. How did they measure length? This is one of those scales that has been discovered. You see these parallel markings? Actually, 3 scales have been discovered at 3 different sites with 9 equidistant parallel markings. And there is enough conviction amongst archaeologists and historians who have looked at these things to say that they seemed to be aware of the decimal system because they always have these 9 parallel markings in those 3 scales that I'm talking about. I couldn't get the pictures of those 3 scales else I would have brought them here at 3 different sites. They also had units of length. See, they had this indus foot and the indus yard. This indus foot is a little longer than the foot that we use. Of course, we don't know if they called it the foot. We label it the foot. They also had what is called the indus yard, which is a little longer than the yard that we use. So these were the 2 standard units of everyday measurement that they used. Take a look at this aerial view of the Great Bath at Mohenjo-daro. Just take a look at all these structures over here. You see they are at right angles and they are completely rectangular or square-like everywhere, right through. Look at this street that runs through. All streets cut at right angles. So they were masters at construction. Look, I could draw right angles and paths on a piece of paper. But to execute it to this degree of precision that if 5,000 years later I take an aerial photograph, the whole thing appears exactly as it was built with the same precision in the angles that you see everywhere. And this is held firm in spite of all these centuries that have gone by. That is also a remarkable tribute to their technology. Look at some of their seals. Look at the degree of the sophistication in the design that has taken place. There are varied seals. All kinds of seals. And all kinds of symbols, by the way. The tragedy is we don't know what these symbols mean. They're still trying to decipher. There are all kinds of theories that go abound on what these seals mean, what the script means. So the real tragedy is that we don't know the script of the Indus civilization. We haven't deciphered that. So we really don't know how they lived, how they ate, how they drank. We can only make these fairly intelligent guesses from all the archaeological excavations. But there is no precise historical chronology by which I could tell you this is how they lived, this is what they did, this is how they ran their cities. Hard to tell. There are other mysteries about this civilization. The script, of course, as I told you, has not been deciphered. Here are some more symbols from the seals which tell you about the script. There are all kinds of, speculation. I'll tell you just one thing very quickly. Because I've been very curious about these matters of history, I found a tribe in Australia and also in New Zealand. It's an offshoot of the Maori tribe, Aborigines in both parts. They also have a language. And it's very different from the kind of language that we have and the kind of grammatical structure that we have in our language. And when they write, so if they have a symbol for a girl, and if there's more than one girl, for plural, they repeat the same symbol twice. You see that? This you will find happens throughout the Indus civilization. There's lots of these repetitions of the symbol. And it's just a personal theory of mine, but I believe that there could be something about plurals here that we haven't figured out. Because no one knows exactly what that symbol means, but this could be a plural thing, because that kind of motive is recurring theme in the Indus series. Anyway, one of the tragedies of the Indus civilization has been, I don't know how you studied history, but when I was taught history and I was taught about the Indus civilization, I think in the 8th grade, I was told it was really a bronze-based civilization. The metal in use was bronze. Fact of the matter is they had enormous quantities of gold and silver. All of it was plundered by the British. The first two cities that were excavated were Mohenjo-daro and Harappa. And all the gold and silver was taken away by the British much before natives, Indians and Pakistanis could get their hands on the excavations. The British had taken away those things. So really there was a lot of the other stuff going around. I may have some pictures, I don't know. But of course this is a bronze dancing girl at Mohenjo-daro. Here are some more ornaments. Some of these are gold, by the way. Okay? So there are lots of ornaments over here. Right, so as I told you, we don't know the script, but none of those things could have been done unless their mathematics was reasonably evolved. I told you about the scales, the weights, the proportions of the bricks. All of that has embeddings of mathematics in it. But then we come to a more definitive movement in India. Just around the time the Indus civilization disappeared. And you know, it is an amazing thing. Roughly around the same time in a period in history, and which is something like 2500 BC, the entire Indus civilization ceased to exist. And no one knows why that happened. It's again a big mystery. Something that may get solved with time, may not. There are many theories. There is one theory that there was a river, some call it the Saraswati River. I cannot say this with any great degree of certainty, but there are fairly serious historians who believe it was the Saraswati River. There was a tectonic shift and the river dried up. And once the river dried up, the civilization was largely dependent at the time on that river. And so it ceased to exist. But in any case, around 2500 BC, when this civilization must have disappeared, and I have some comments, personal comments on that, another civilization began to spring up in India in the same region, same geographical region where the Indus civilization existed. That's the Vedic civilization. And why do we call it the Vedic civilization? Because this civilization has a hallmark. The Veds, the four Veds, but primarily to begin with, the Rig Veda was composed as this civilization began to evolve. And the civilization revolved around the Veda, the Rig Veda, and then the other Veds. So that's why it is called the Vedic civilization. Almost all historians say that this civilization came after the Indus civilization. And you know, there were so many sites, I only showed you 8 or 10 of them, but there are literally about 100 places where the Indus civilization existed. The Vedic civilization also developed around the same region. But you know, none of the Veds, and more specifically the Rig Veda, in its entire text does not ever use the word city or brick. Totally missing from the Rig Veda. And so I have a hypothesis, it's just a hypothesis, that probably the Vedic civilization may be prior to the Indus civilization, because I find it hard to accept that the Veda is such a deep text, such a thorough text. It describes, it was thoroughly familiar with geography. It describes the entire geography of the region, in every sense of the term, the rivers, the forests, the mountains, nature, animals, everything is thoroughly described there. They were completely aware of the nature of the whole place. But they never once talk of a brick or a city. And I find it very hard to accept. How could they do that when the whole civilization already had existed before them based on cities which were totally built with bricks? And you'd have to find them. So I want you to think about this. Maybe the Indus civilization came after the Vedic civilization. It is quite possible. It's a great mystery. To my mind, it's an enormous mystery. But be that as it may, and the larger view that prevails is that the Vedic civilization came just when the Indus was disappearing. Let's mark the date as 2500 BC. Even that is 4500 years before our time. So that's a pretty sophisticated time. This civilization is known for many things, the Vedic civilization. I am largely dwelling on its mathematical discoveries. They are amazing discoveries, and they date back to a long time. All this stuff that I show you, these texts, etc., they got written much after the time of Christ. Before the time of Christ, all the knowledge embodied in all the Vedas, all the other texts, the Satpat Brahmans and the other texts, the Vedants, the Upanishads, all of that was totally oral. And I want you students to think about this. It has become fashionable in India now to de-emphasize the use of memory. To my mind, it is a bit of a tragedy. You know, we are so happy to use a computer. We are so happy to make this use of the computer repeatedly. The computer would not be the computer unless it had a well-built memory inside it. It's the memory that makes the computer what it is. This ability to randomly access any part of its memory storage makes the computer what it is. And we in India, in our educational system, in today's times have de-emphasized this use of memory. I'm told in schools they don't even ask the students too much to memorize multiplication tables. Believe you me, you know, it is not easy for you to grasp the significance of what I'm telling you. If you were very good with your tables beyond 20, you will have no difficulty in anything in life. Not just maths, to do well in life. It's very hard for you to understand this now. I'm passing on to you a wisdom that others have passed on to me. Even I skipped my tables. And I regret that now. It may be too late for you, maybe not. Try and memorize. I'm not asking you to blindly memorize, but you must embed into your systems the great features of knowledge which you can access as and when time demands, and that requires good memory. You must develop that. Don't be blind, don't be a parrot, but you must have memory and use it intelligently. So create those systems. It's still not too late for you. As I was telling your faculty colleagues some time back, you know, people say that wisdom is a comb that life gives you after you've lost your hair. So I've lost my hair, you know, I'm passing on this wisdom to you, I'm giving you this comb because you haven't lost your hair yet. Use that to good advantage. That's why I'm giving it to you. The Vedic civilization was a totally oral tradition. When I tell you the kind of maths that they had, it's amazing that they could do all of that in their heads with such degree of sophistication. Let me just go to this text which dates back to 900 BC, the Satpat Brahman. It's a sophisticated text. It has all kinds of mathematics. This text got written down after the time of Christ, but it dates back to 900 BC. You can date it back very accurately with scientific methods to 900 BC. Amongst other things, I particularly chose the theorem of Pythagoras. The theorem of Pythagoras is something all of us learn in school. It's a remarkable theorem. It's a very beautiful theorem. Mathematics is all about symmetry. This theorem is also about symmetry. If you go deeper into maths, you will realize what I mean. It's enormous symmetry in the theorem, and all of quantum mechanics is developed through symmetry. So there is deep truth embedded in this theorem. But leave that aside. It's also useful in everyday work. So the theorem is important from all points of view. We all know it as Pythagoras' theorem. What we don't know is that the Satpat Brahman, 400 years before the time of Pythagoras, states the theorem clearly, very clearly. To this, Western scholars tend to say, of course, they could have stated it because you could have made an empirical discovery of the theorem. You see it in everyday life and you measure the sides of a triangle and suddenly you see, oh my God, the squares add up to the square of the hypotenuse. Great. First of all, even that I think is a great discovery. But it isn't just that. There has been this tendency in the West to criticize that Indians did not know enough about rigor. And the thing is that they knew enough about rigor. They knew a proof of this theorem. The Upanishads evolved around the Vedas. And each Upanishad, I don't mean the Upanishad, the Shulva Sutras, they evolved around the Vedas. And each Shulva Sutra had an author. Each of these authors was a mathematician. And in the embeddings of the Shulva Sutra are mathematical theorems with proofs. Perfect proofs. From the modern viewpoint. And what does it have to do with the theorem of Pythagoras? Well, I'll come to that in a minute. So, I want to tell you something. There is enough evidence to show that Pythagoras came to India. If you look at Apollonius' writings, Apollonius was a disciple of Pythagoras. He writes that his master went to India to learn from the Brahmins. And I went to Indore, which is a great center of Indology, ancient Indian research in ancient India. They're great experts there. And I went and asked them, I went and spoke to the experts and I said, so do you believe Pythagoras came to India? And they told me, what is there to believe, which is accepted in our tradition. He came to India, got influenced by Jain thought and became a vegetarian. And not only that, they tell me he used to eat before sundown like the Jains. It's a totally accepted tradition. But it isn't just this that I talk about it. I told you, Apollonius writes. But it isn't just Apollonius. A professor many years ago, about 60 years ago, at the University of California, Berkeley, writes in his historical research that there is enough evidence to show that Pythagoras came to India. You will not find generally Westerners accepting the fact that Pythagoras came to India. They don't want to talk about it. Why am I telling you this? This theorem was discovered much before he came to India. It was in use in India. There's the reason why it was in use in India, I will tell you. For practical everyday needs, the theorem was being used. The story doesn't end there about Pythagoras. If you've heard of Voltaire, the great French thinker, if you look at Voltaire's writings, again he writes clearly that Pythagoras came to the banks of the Ganga to learn from the Brahmins. And he also writes that he finds it difficult to believe that he could not have learned of the theorem when he came to India. I'm not trying to say he stole it, but let's accept the fact that in the West they can't go before the time of Pythagoras to talk about the theorem. But they will never say he came to India and that the theorem was in India 400 years before Pythagoras. They don't want to talk about that. So you think about this. This gem of mathematical research existed in India so many hundreds of years before Pythagoras. Well, there are many great things in this theorem. Let me just tell you. What is a Shulva Sutra? Shulva actually means a piece of cord or string. And Sutra is a formula or an aphorism connected with the string, with the use of the string. What was really going on is that when the Rig Veda was being practiced, if you have any idea of Hindu rituals, and I'm not trying to propagate any religion, so please don't get me wrong, this is purely from the point of view of academics. In the Hindu religion, every single ritual centers around a fire sacrifice. And all fire sacrifices are performed in a specific fire altar. For different sacrifices, you have different shapes of altars. I may have some shapes. You can already see this shape here. This is a fire altar. You see this thing here? It's a fire altar. And you can see it's a square in a square. Actually, in this shape itself is the theorem of Pythagoras. I'll probably try and show it to you how that happens. But the theorem of Pythagoras is embedded in the construction of this shape. But all these rituals, as I said, require different shapes for different things. If a farmer wanted a good wheat crop, he would get the priest to come and perform a sacrifice that would give him good rains. And for that, the priest would then construct a very precise geometrical fire altar, different types. Maybe I have pictures here. Yeah, you look at this. This is a fire altar, by the way. It's in the shape of a bird. It is in the Shulva Sutra of Katyayana, who was in 200 BC. And Katyayana also states and proves the theorem of Pythagoras, by the way. Of course, this is just a specific fire sacrifice altar that Katyayana constructs in his Shulva Sutra. He was one of the authors of one of the Shulva Sutras. So the Shulva Sutra, as I told you, is a piece of cord and formulas connected with that. And all these texts are named after the mathematicians. So there's a Shulva Sutra of Bodhayan, there's a Shulva Sutra of Katyayana. Altogether, to my mind, I think about a dozen or so Shulva Sutras survived, or less maybe. There were, I think, 16, and many have been lost. But you can tell that all these texts existed because one text refers to the other. So by the cross references, you can tell there were so many Shulva Sutras that existed. And they all talk of very sophisticated mathematics. I just picked up one. Why? Because all these fire altars not only had precise shapes, they had to conform to precise notions of area. So those mathematicians understood area extremely well. They understood how areas went. You see that? This is really the theorem of Pythagoras once again. I do not have a chalk and board, else I would have explained this to you. I tried to add an animation here, but I don't think it will work because I think I missed out on a supporting file, an exe file for the animation. Okay, In 800 BC, Bodhayan talks of the theorem of Pythagoras. As I said, he talks of other things in his Shulva Sutra, but he talks of the theorem of Pythagoras. This actually is from the Katyayana Shulva Sutra. It's really the same fire altar that I showed you in a three-dimensional shaped version. It's exactly this. Well, how is the theorem of Pythagoras embedded here? It so happens that if you take this right angle triangle, you see that? You can treat this line as the hypotenuse and this as the other two sides. You are required to show that the square of this side plus the square of this side is equal to the square of this side. And to do that, what you do is you construct a square like this. This square is nothing but the sum of these two sides to make it square. See that? This and this add up here to make this square. So if you call this A and you call this B and you call this C, then you're required to show A square plus B square is equal to C square. What you do is you look at the area of the larger square. What's the length of the square? It's A plus B. So the square has area A plus B the whole square, which is A square plus B square plus 2AB. You know the formula for that. A plus B whole square. It is also equal to the area of this smaller square and the four identical triangles. The area of the smaller square, because the side is of length C, is C square. And if you combine these two triangles, you get a rectangle of side A and B, and these two triangles make a rectangle of side A and B. So the four triangles add up to areas of AB, which is 2AB. So 2AB plus C square is A square plus B square plus 2AB. So you cancel 2AB from both sides, you get A square plus B square is C square. That is the proof of Katyayana. Bodhayan also gives a proof in 800 BC. It's a different proof, but he also gives a proof. So this Western criticism that Indians did not know this art of proving a theorem is not correct at all. And I want you to understand this. It is important, as I will come later on in my lecture. But the Shulva Sutras are not just about the theorem of Pythagoras. There are many things that are existent in the Shulva Sutras. They understood irrational numbers, square root of 2, square root of 3, and they understood how to compute them. Of course, they did not use the word decimal, but with the methods of computation as outlined over here, you can actually compute them correct to so many decimal places. This is happening, hundreds of years before the time of Christ, when all of Europe was living in caves. That's the time this was happening. I come now to another time, 500 years before the time of Christ. Panini. Many of you must have heard of him. This is a stamp. No one knows what Panini looked like. That's another thing about the Indian mathematicians and scientists in general of those days. They had no ego. Nothing. They never talked about themselves. When Bodhayan writes his Shulva Sutra, of course it is an oral tradition, so they have to make it in poetry, crisp Sanskrit, terse poetry. Aphorisms, so that you can easily memorize. But not once does Bodhayan say, I come from this region, I am so many years of age, I have a wife and 3 children, I work over here, I don't like that fellow, I learned from that fellow. Nothing. There is nothing. We have no idea where Bodhayan learned. They liked to remain anonymous. There were no ego issues here. They only worked on knowledge for the sake of knowledge. They wanted this knowledge to be transmitted in pristine form from generation to generation, and that is why till today it has survived. If this oral tradition hadn't been there, who knows, the text could have been mutilated, destroyed in a fire or something like that. But that oral tradition held, and it wasn't blind memorization, because each generation, when I look at the succession of the Shulva Sutras from 800 BC onwards till the time of Christ, each Shulva Sutra is building on more knowledge from the previous sutras, doing more research. All through memory. So memory is not hampering original thinking. Please remember that. There is this wrong view prevalent that if you do rote memorization, well, of course, you're just doing that and don't do anything else. It's going to harm you. But they weren't doing that. You have to be a living person. You have to think beyond this rote memorization. So I come to Panini. He was a great man. He was given the honorific title of Bhagwan Panini. Why? Because he invented this perfect Sanskrit grammar. Perfect Sanskrit grammar. It's precise logic in mathematics.
There is no room for doubt or ambiguity. All the rules follow in precise mathematical way. Only someone with the stature of a god could do that, so they called him Bhagwan Pandit. I also want you to know something else. I don't know how many of you have heard of Noam Chomsky. He's a professor at MIT. He's called the Albert Einstein of the liberal arts and humanities. Why? Because about 40 years ago, Chomsky gave his theory of linguistics. It's a remarkable theory. And it created a revolution because it teaches us how grammars evolve and what are the underlying rules of grammar. But I haven't heard a single Indian tell me that Chomsky's entire structure comes because he has studied Panini's grammar. Who told me this? Fritz Stahl, one of the greatest living researchers on the Vedas. He comes from the Netherlands. He toured the length and breadth of India on a motorcycle. He understood. He's a great scholar of Sanskrit. When he first attended Chomsky's lectures in the 60s at MIT, he immediately realized this is nothing but Panini coupled with mathematics. So he went up to Chomsky and he asked him, and Chomsky said, sure, that's where my ideas are coming from, Panini. And why aren't we doing that? Because the only people who study Panini in India are people from Sanskrit. No mathematician, no scientist looks at Panini. That is the tragedy that India has today. Raji has built this university and he has consistently said this is seamless. No borders between disciplines. If you start doing that, you will die out. If you have borders, you will kill yourself, you will kill the country. This country did not grow like that. Panini knew mathematics and he knew linguistics and he knew poetry. So you must understand this business of cross-discipline, interdisciplinarity is extremely essential to intellectual growth, to the well-being of society. You can't have an engineer who says, I don't know chemistry. It is impossible. That's why you will build bridges that will collapse after 20 years because of corrosion. Because the engineer hasn't understood that the metals and the other composition elements that he has used there will corrode because of chemistry. You cannot allow that to happen. But in India, we are compartmentalizing ourselves. Not one Sanskrit professor, not one knows any mathematics. If they did, all of them would be Chomskys. All of them would be called Einsteins. Why am I telling you this? Because please don't close your minds to other realms of knowledge. The Rig Veda says in one of its first verses, let noble thoughts come from every direction. What a great and liberal thought. What a great idea. You must allow ideas to come from every sphere. Absorb that and grow with that. If you could do that, you would do what Panini did, you would do what Chomsky did. Why am I mentioning Panini otherwise in the context of mathematics? Because he's the first person who talks of the concept of zero 500 years before Christ. He uses the word shunya. Not only that, he invents a symbol for it, the dot. Panini invents a symbol for zero, the dot. And the dot gets enlarged into this circular thing that you now use for zero. There is no other history behind the use of the symbol for zero. So Panini understood the importance of zero. Then I come in 200 BC to Pingal. Pingal was a prosodist, a person who dealt with poetry. He was trying to create new meters in poetry, All poetry is nothing but about meters. If you ever like a poem, no matter what language, Hindi, English, Urdu, Persian, Sanskrit, whatever, German, you will notice it is based on certain specific meters. All sounds are based on that. And the Indians understood this very well much before Christ, this business of meters, the long and short sounds, and various combinations of them. Pingal was an expert on that. And so through poetry, Pingal began to make permutations and combinations of different sounds. And when he began to do all that, he realized something amazing. He discovered that the binomial numbers, the coefficients, I'm sure all of you know the binomial theorem, and the coefficients in the binomial theorem, n choose 1, n choose r, etc., etc. Pingal spotted them. And guess what he did? He created an object called the Meru Prasthar. Literally translated, the Meru Prasthar means steps leading to the mountain top. Meru is a mountain top, Prasthar are steps. Steps leading to the mountain top. You know what I'm talking about? I'm talking of Pascal's triangle. Pascal's triangle was discovered by Pascal 17th century in Europe. It is one of the cornerstones of probability theory. Ascribed to Pascal 2000 years after it was discovered in India and used in India. And where did the use come from? Poetry. Once again I re-emphasize, keep your minds, ears open to all disciplines. You have no idea what will come in handy where. All this mathematics that Pingle used, he must have known it. It isn't that he decided one day, okay, I'm going to make mathematics here. In his entire process of studying in the Gurukul tradition, he was a rounded personality. He wasn't just famous in poetry, he understood other things, and so he used everything to create this Meru Prasthar. I have a picture here. He was trying to invent new meters from the known Vedic meters. If you look at the Vedas, they have these standard meters, Gayatri, Anushtap, Prati, by varying the syllables through permutations and combinations of long and short sounds. This led him to discover the Meru Prasthar. Here's a picture of the Meru Prasthar. See that? Steps leading to the mountain top. These are the binomial coefficients. And now here's an amazing consequence of this. In the 12th century, so Pingle wrote a book, the Chanda Sutra, again in the oral tradition, but the book survived in the 12th century. And in the 12th century, another Brahsodist came along who decided to write a commentary on Pingle's book called Halayut. Halayut wrote a commentary. And when Halayut wrote the commentary and he looked at the Meru Prasthar, he actually discovered the binomial theorem. So 500 years before Newton, the binomial theorem was discovered in India. In my entire school life and even my college life, I was told that Newton discovered the binomial theorem. Newton, of course, was a great mind, one of the greatest minds that ever lived. But it's nice to know that we Indians could also do our own things much before them. So the binomial theorem got discovered here in India, Halyut in 1200 AD, exactly in the way I stated here, using the same coefficients that you find over here. All those coefficients, he discovered the binomial theorem. At the same time, when all this was being discovered in the business of Vedic mathematics, because the Vedas were being developed and practiced, we must not forget that Jain and Buddhist mathematics was also evolving at a fascinating pace and hand in hand. I have read accounts by Western historians in the last 3-4 years. This is emerging research that taught that the Jain mathematicians understood infinity extraordinarily well. You know, in the 20th century, the beginning of the 20th century, there came along a German mathematician by the name of Cantor, George Cantor. Cantor broke the mold in mathematics. He began to think in terms of understanding that there are different sizes or orders of infinity. One infinity can be larger than another. He began to master infinity. He actually tamed it. He categorized different kinds of infinity. The work that Cantor did had amazing consequences. It's an amazing story that Cantor did. The tragedy is that in Cantor's time, when he made these discoveries, mathematicians could not accept his logic. And they attacked him ferociously. The greatest living mathematician of Cantor's time, Poincaré, who also discovered relativity a little before Einstein, but never got credit for that. This Poincaré said that this stuff that Cantor has done is a disease that 20th century mathematics will have recovered from. That's what Poincaré said. And it was enough to destroy Cantor as a human being. He ended up in a mental asylum where he died. He couldn't take this criticism. So mathematicians can also be pretty strange people. Here is the eventual situation with Cantor's theory. Poincaré says at the beginning of the 20th century that what Cantor has done is a disease that 20th century mathematics will have recovered from. At the end of the 20th century, some of the world's finest living mathematicians write this great monumental treatise, which is the foundation of all mathematics. And what do they write over there? They write that today all of mathematics can eventually be reduced to just two concepts, that of a second accomplished, what Cantor had introduced in his theory. So how many lessons do we infer from this? Don't make stupid predictions. Don't be prejudiced. Learn to accept people's ideas. Don't go after them. Look at what Poincaré said. History will never forgive Poincaré, who was so great, because he could not see the greatness of Cantor's work. And why do I say all this? As I said, Cantor's work forms the basis of all mathematics. But these giants, before the time of Christ, as it seems apparent now, had also done more or less the same work. That is the amazing thing of India. Those are the genes that reside inside you. Take pride in that. Do not be overconfident, but certainly take confidence and pride. But the fact is that it grew in this very land, this very soil that you and I partake of. So be at least confident about the fact that we can do these things. The Jains also understood how to represent really large numbers. The Greeks had no idea. Have you seen how the Greeks represent numbers? People talk so much about Greek maths, all the logic that they developed in their geometry, Euclid's mathematics. But they never talk about the fact that the Greeks had no idea how to write large numbers. Have you seen how they represent numbers? XB111. What does that stand for? 18. My God, how many symbols have you used? How many times? Would you be able to represent such large numbers? No, but the Indians before the time of Christ could represent these numbers. The Jains also knew the laws of indices. That's another remarkable thing, how to add these indices, how to manipulate them. They knew them very well. There is evidence, as I said, that they understood the theory of Cantor. That was amazing. This is hundreds of years before Cantor. I now come to something amazing. This is what is called the Bakhshari manuscript. All this was in the oral tradition so far. Everything was oral, being transmitted from generation to generation. Got written down much later. When did we start really understanding that there was so much that had happened? This manuscript plays a monumental role in this story. This is an early mathematical manuscript written on birch bark and found in the summer of 1881 in the village of Bakhshali. Then India and now unfortunately Pakistan. I don't know why we keep dividing things. Humans love to divide. They don't like to share. Don't allow that to happen. At least with knowledge, share your knowledge. Let it go and it will enrich you even more. Do not be like that. Anyway, what happened was there was this man who was plowing his land, actually trying to excavate something so that he could build a new structure. And he came across this manuscript. Only 60 odd pages survived. It was a much larger manuscript. It's a manuscript on mathematics. And the interesting thing is that this manuscript is dated back to about the 3rd century AD. So that dating is more or less certain. Where does this manuscript reside? It resides in the British Museum in London. It is not in India. Or probably at Oxford, but not in India. You will find the photocopy of this manuscript at the National Museum in India. I don't know if Pakistan even has a photocopy of it. I don't know if they realize the value of this. I wish they would and ask it to be sent back. But forget all that. What is this manuscript about? It is a commentary on earlier mathematical work. And that earlier mathematical work predates Christ. So the Bakhshali manuscript is clear written evidence of work that has preceded Christ, mathematical work. And what is it about the Bakhshali manuscript? Well, it gives you clear use of the decimal system. That is the breakthrough. That is why the decimal system is ascribed to India. Otherwise, they would never let us take credit for it. It is ascribed to India because here is this hard evidence in the Bakhshali manuscript of the decimal system being in use since before the time of Christ. But the Bakhshali manuscript has amazing things in it. So many marvelous things. All of you in school have learned to solve quadratic equations. The Bakhshali manuscript deals with quadratic equations. All of you understand how to manipulate mathematical figures, fractions, things like that. All of that dates back to the Bakhshali manuscript. It actually tells you how to write fractions in exactly the way that you write them in modern times. Let me just show you. So about 70 pages survive. It is a commentary on an earlier mathematical work, gives clear evidence of the use of the decimal system. Here is how it was discovered. It is in Oxford, by the way. Here's an actual photo of a page from the Bakshali manuscript. Okay? You can actually see some mathematical symbols there, but let me just show you something more. So the symbols, the numerals that are being used in the Bakshali manuscript are something like this. These are the Brahmi numerals. You see that? 1 is as it is, you see there, it gradually gets vertical from being horizontal. 2 is nothing but connecting the two parallel lines and just elongating the whole thing. That's how 2 became. 3 is just connecting the 3 parallel lines. 4 is just connecting one side of the 2 ends of the bar there, the cross there. You see that? That's how the Brahmi numerals were, and they are in use in the Bakshali manuscript. So these are the progression of the Brahmi numerals over these centuries. Okay? These are the numerals found in the Bakshali manuscript. This first thing over here is 330. 8 is that 840720. 840720. And 947. So they used these numerals to good effect, and of course nobody in Europe had any idea of how to use the decimal system at that time. Here is how they use fractions. This is actually 3 upon 4. They just didn't write the bar below it. But when they wanted to denote 3 upon 4, they wrote it like this. 1 upon 2. If they wanted to subtract 1 upon 2 from 3 upon 4, they would write the plus sign on the right hand side. Nowadays we invent a new sign, minus, and we put it in between. But this is how they subtract it. Exactly almost as we do it today. And this was so many hundreds of years ago. Here are other contents of the Bakshali manuscript. They knew how to solve linear equations with as many as 5 unknowns. That's fairly remarkable. Quadratic equations, arithmetic and geometric progressions, simultaneous equations, fractions, things like that, including use of 0 and the negative sign by putting plus on the right hand side. A remarkable method to compute square roots. That's really amazing. Here is the method, and actually gives you, it is faster. People who have actually used it through their programs in numerical analysis tell me that it is faster than the standard methods that exist. So in many ways, I think this method is in use already. Then I come to the 5th century AD. I talk about Aryabhat. Incidentally, as I told you, no one knows, what Aryabhat looked like. This is a statue of Aryabhat at the Inter-University Center for Astronomy and Astrophysics in Pune. And so I would like to believe this is what Aryabhat looked like. It is fairly, typical of a scholar in those days. They would actually be more or less like this. Aryabhat was a remarkable man. He was 21 years of age when he wrote his most famous book, the Aryabhatiya. In this work, he records many important discoveries in mathematics and astronomy. He was really great. He was a greater astronomer than mathematicians. And do you know he was a professor at Nalanda, this famous university that existed in those times. Aryabhat gave many revolutionary ideas, many ideas. Let me first talk about his astronomy. He understood the essentials of the Copernican system. So Aryabhat writes very clearly in the Aryabhatiya that the earth is spherical in shape. He says, Kadamb ke pushp ki tarah gol hai. Spherical. Have you ever seen the kernel of the kadamba flower? I don't know if Raji has put a kadam tree on the campus. But if you have, and when it flowers, go take a look at it. If Raji remembers at St. Stephen's College there is a kadam tree. The moment I learned there is, I went and took a look at the flower. Perfect sphere. And Aryabhat says, Kadamb ke pushp ki tarah gol hai. Then he says that it appears that the sun goes around the earth, whereas it is the other way around. And he says that the earth revolves around its axis. And he draws a marvelous analogy. Again, just like the Kadamb push. He says that the sun appears to move around the earth, whereas the earth is revolving around its axis in exactly the same way as if you are in a boat going downstream in a river and you look at the trees planted on both banks of the river, you will feel as if the trees are moving, whereas it is actually the boat that is moving. In exactly the same way, the sun appears to move, whereas it is the earth that is moving. And do you know, not everyone in Aryabhat's time agreed in India with Aryabhat's understanding. So in Nalanda itself, there are scholars, mathematicians, astronomers who criticize Aryabhat. But they say we accept his mathematics, very good mathematician, and so they make him a professor. Hundreds of years later, when Copernicus comes across and he propounds his theory, the church goes after him. In India, they never did that. We come from liberal traditions. And what did they do to Bruno, who propounded Copernicus' theory? They burnt him at the stake in Europe. Take pride in the fact that we have never been like that. We are tolerant. We are liberal. So they didn't agree with Aryabhat's analysis of what the earth does, but they recognized his scholarship and made him a professor. Stay with that tradition. These are the lessons I want you to imbibe. What are Aryabhat's discoveries? As I just mentioned, he also discovered the value of pi correct to 4 decimal places. He gave methods of finding square roots and cube roots. He was the first mathematician in the world to give a general solution of this equation. This equation has stumped all kinds of people for a long time after Aryabhat in Europe. They just didn't know what the Indians had done. But when you look at the Aryabhati, all these solutions are there in his book. He put Indian astronomy on a firm mathematical foundation. So Aryabhat understood that unless mathematics is used properly in astronomy, we will have trouble. So actually by then, by Aryabhat's time, people had begun to miss out on eclipses. When they would predict that an eclipse would take place at this time, they would be off by a day or two. And Aryabhat realized that the mathematics that was being used was not properly used, not properly in place. So he recast Indian astronomy on deep mathematical foundations. He made remarkable contributions because the entire calendar after that has remained unchanged in Indian astronomy. It just works perfectly well. After Aryabhat came Brahmagupta, 598 AD to 670 AD. Again, we don't know much. Of course, we don't know what he looked like. I've just tried to imagine this must be Brahmagupta. Please take it with a pinch of salt. The important thing is, as I told you, even Aryabhat doesn't write anything in this big book that he writes. Only one thing, that I'm 21 years of age. That's all. In this year, when I am 21 years of age, I am penning this book. And no more. Nothing. He doesn't say a word about himself. No ego. Brahmagupta was just like that. So he was the foremost Indian mathematician of his time. He made advances in astronomy and in number theory. For square roots and stuff like that, he was really unparalleled. Here is what Brahmagupta is really famous for. This is called Pell's equation. It's a deep mathematical problem. So deep that the finest mathematicians of Europe hundreds of years later also couldn't solve it. And Brahmagupta actually understood how to solve it. Now these are things that come from algebra and number theory. Remember this, 2 of the deep branches of mathematics. And we in India had whole schools. It wasn't that Brahmagupta sat in isolation and he solved it. Brahmagupta was part of a school. Brahmagupta's pupils, Brahmagupta's teachers, they all followed his word. It's just that many things have been destroyed. You know, the libraries at Nalanda and Takshashila were completely destroyed. These were 2 of the greatest centers of learning in the world. And to my mind, I trace the descent of India, the decline of India from the time that these 2 libraries were burned. Because in those days, Indian society, Indian governmental systems, rulers, interacted closely with scholars for science and technology. It weren't that they were isolated. Society took and gave to these systems of learning. And that is why India prospered. And you can see a clear decline in India as a civilization after the 2 libraries are burned. Just try and imagine, suppose for the sake of argument, all the knowledge that exists today is put onto server systems. And some sort of electrical sun-solar activity happens. And all these server systems are completely wiped out. What do you think will happen to the world today? We have suddenly lost almost all knowledge as it exists. It will have to be rebuilt again. Something like that happened to India when these great repositories of wisdom and knowledge were completely destroyed. He also discovered a formula for the area of a cyclic quadrilateral. It's a quadrilateral inscribed inside a circle. Did many other things. By the way, these are deep things. But here are 2 things I want you to see that he did. He was the first to obtain formula for the sums of these series. You use these series, all the time. I don't know when you do that, in school probably or in college. Brahmagupta actually was the first to write what these sums meant, and he knew exactly how to sum them up. These aren't things based on sudden discoveries of some empirical observation. He had proofs for these things. Another thing I want to tell you, trigonometry as you know it, I'm sure you've studied it in school and I'm sure you're studying it even now. You use lots of times sine and cosine and stuff like that. Almost all of trigonometry as you have studied it originated in India. Do you know how the words sine and cosine have been coined? In India they were called jya or ji for sine and kojya or koji for cosine. And they used trigonometry because they were studying planetary motion. They were astronomers. And you couldn't do all this without trigonometry. That's why trigonometry developed. The knowledge that we developed went to the Arabs. And the Arabs made a phonetical translation of jya and kojya. They didn't make a literal translation. They didn't want to figure out what is the meaning of jya. As a sound, jya got translated to jab in Arabic texts. And kojya got translated to kojab in Arabic texts. And from the Arabs, this trigonometry went to Europe. And the Europeans made a literal translation of jab. Jab in Arabic actually means a bosom or a pocket. And so they translated it into sine. And therefore kojab became cosine. And that is the entire story behind how these terms came about. But the origins are entirely Indian. And it isn't that they were only using trigonometry. They were using trigonometry because they were studying astronomy. What was astronomy about? Planetary motion. And one of the foremost, so this is the story behind sine, cosine. These are the terms they had. They knew all these functions. Cosine, inverse sine, tangent, secant. They knew all that. They also understood sidereal years, tropical years. Leave all that aside. I want to come to Bhaskaracharya. Bhaskaracharya was in the 12th century AD. He was doing the same thing, using trigonometry to study planets. When you study planets, you want to understand how they move. What is this business of motion? And you know, why did Newton discover the calculus? For the same reasons. He was looking at the movement of planets. And he wanted a way of writing down instantaneous velocity. So he invented the calculus. And for that reason, Newton is called one of the greatest minds that ever lived. Justifiably so, correctly so. He was a great mind. What we don't know is that many hundreds of years before Newton in India, Bhaskaracharya was also doing the same thing. And Bhaskaracharya uses a term for the derivative, tatkalik gati, instantaneous velocity. That's the literal word he uses, tatkalik gati, instantaneous velocity. And he knows and he writes that the derivative of sine is cosine. He says that categorically in his text. Just imagine, we all say that calculus was discovered in Europe by Newton and maybe Leibniz, and they had a fight as to who discovered it. The irony is that it was discovered hundreds of years before either of them in India. Bhaskar was a distinguished mathematician who made other contributions. He understood that if you divide by zero, it's something like having infinity. He was the first to observe that a positive number has two square roots. He understood properties of surds. He actually dealt with unknowns. He knew how to solve all these equations. Equations with more than one unknown, stuff like that. He discovered the derivative, called it tatkalik gati. He also discovered Rolle's theorem, by the way. I'm sure you do this in school somewhere. So he also knew that. He gave the cyclic method. So he gave the final solution of Pell's equation. And you know, one of the greatest mathematicians of modern times in Europe, Lagrange, says, who also studied Pell's equation, that just this single bit on Pell's equation that Bhaskar did is enough to rank him amongst the great mathematicians of all times. Here is something remarkable that Bhaskar did. You know, what is algebra all about? But symbols, x, y, z. We use them all the time. When did algebra begin with Bhaskaracharya? He is the first to use symbols for unknowns. That is the story of how unknowns were denoted by these symbols, and that is how Europe took up from us. All this went to the Arabs, and from the Arabs it got transmitted to Europe. He could compute pi, he knew all these trigonometric formulas. He writes all this, this is in his text. And I come to Madhavacharya. There are hundreds of people, I haven't spoken about so many of them, but I come to Madhavacharya. Remarkable man, simply along the same lines as Bhaskaracharya. Bhaskaracharya I think was in Indore, Madhavacharya was in Kerala. The whole of India was one big learning place. Seamlessness, as Raji said, things move from one part of India to the other without effort. Knowledge was transmitted. You know that any person who came to learn was never impeded at any border of any part of India. That is why Fahyan and Yuan Sang came all the way from China to learn at Nalanda. No one stopped them. They were granted admission. Everything was free and open. Knowledge is all about being open. Madhavacharya was in Kerala and he had all the methods of the calculus for which Europe has become so famous. He understood how to write Taylor's series of functions. And he writes the Taylor series of tan inverse x. I'm sure you've done Taylor series if you've done any calculus. He writes the Taylor series of tan inverse x and uses that to compute the value of pi. Correct to many, many decimal places. Of course, he's using the decimal system and everything else. So Madhavacharya was really, and he was also an astronomer studying the movement of planets. That's why he was doing all this calculus. But of course, as I said, he's about 300 years before Newton. So see how much India had progressed. So much had been done in the Indian tradition. I've just given you a small glimpse of what India was like. And remember, no mathematics occurs in isolation. It has to develop hand in hand with technology, science, other disciplines. And they all feed on each other. Everything works to the betterment of the other. That is how knowledge develops. So this did not happen in isolation. It isn't that suddenly Indians said we'll do maths and everything else was not done. That is the story of Indian civilization. I have already told you, I come to the final part of my lecture. Talk about Srinivasa Ramanujan. Ramanujan didn't come out of thin air. That is the thesis of my talk. He is part of the Indian tradition. This is how India has been. This is the strength of India. The genetic pool in India always asserts itself. And the story doesn't end with Ramanujan. It goes on and on. It's just that many of you are not acquainted. But Ramanujan's story is remarkable. It is romantic. There is tragedy in it. But above all else, there is mathematical glory in the story. And you must be acquainted with this story for all kinds of reasons. I want the young here to understand and embed this in their hearts. He was born in 1887. This is the home where he was born. It's actually just what you would call a small kasbah. He was a self-taught genius. He was a self-taught genius. He was born in such a poor family that they could not afford to properly have 2 square meals in a day. They were really in a bad situation. There's another thing you must know, that Ramanujan could not speak, read or write till he was 5 years of age. He had something in common with Einstein. Even Einstein couldn't do that till that age. Now I want you to reflect. I don't know what happens in other parts of India, but up until very recently, in Delhi, if you ever thought to take a child to be admitted to kindergarten and school, they would do an interview with the child. And if they thought the child wasn't performing well, they would eliminate the child. And maybe they still do that. I don't know. Schools are very quirky places in India. I despise them. By this process, by this logic, by this system, they are eliminating all potential Ramanujans and Einsteins. Think about this. Just think carefully. We must be a thinking nation. And if the youth don't think, nation is destroyed. So please think. You must speak up. You must assert yourselves. You must assert yourself for the well-being of society. What you give to society will come back to you. But you must do that. And I will tell you, even Ramanujan did that. When the time came, he stood up for the well-being of society. So you must do that. Why do we allow such processes in education to thrive? Or other evils in society? You must also speak out against corruption. It is eating the very fabric of our society. It is destroying the well-being of the nation. And do not ever accept corruption. Stand up, otherwise everything will be lost. This great tradition that I speak of will be gone. These monsters who deal in corruption will eat us all up. Do not. We take it lying down. Don't let that happen. I just want to speak about just some discoveries of Ramanujan, but you must understand his story here. Not so much on his mathematics. As I said, he couldn't speak, read or write till he was 5 years of age. And his mother got worried. Mothers are wise people and They are so wise that they will never ask the husband's family to do anything. They'll take them to their own family. I'm sure Rajji will agree with me. All wives do that. Any problem they first check with their own parents on how to solve it. And I admit it's correct. Am I right, Rajji, on this? Yeah. He agrees with me. You have to. We have no choice in this. Ramanujan's mother took Ramanujan to her father and said, he can't speak, read or write, do something. Father was just as poor. Couldn't afford pen and paper. So he took, you see, people talk so much about technology, now education mein sab theek ho jayega, ye use karo, computer use karo. Kya kiya Ramanujan ke father ne? He took grains of rice, spread it on the floor. और एक लकड़ी लिया और Tamil letters के alphabet उस rice पे carve करने लगे. Started carving the letters of the Tamil alphabet. उसी से रामानुजन के दिमाग में दीप जल गया. He started on his journey. Something worked inside him. And he began to learn, read, write, speak. And sure enough, then the mother brought him back and put him into a school. And as luck would have it, somewhere he started enjoying mathematics in the school. And when he was in the middle school level, he was already set on his journey. He was way ahead of what was being done in the class. कोई घर में नहीं था. No one could tell him what to do with maths. People in the house were illiterate. Teachers भी ordinary थे. Imagine in those days क्या रहे होंगे, क्या technology रही होगी, क्या school रहा होगा इस छोटे से कस्बे में. But Ramanujan खुद से आगे बढ़ने लगे. क्यों बढ़ने लगे? He discovered his dharma. You know, education is all about finding yourself. It is a journey of the discovery of the self. और कोई meaning नहीं है education का. And this process will never end. You know, जीवन पर्यंत आप समझते रहोगे who are you, what are you. Inner calling को निकालना पड़ता है बाहर, and you pursue that to the best of your ability. This dharma will take you to your God. That is what happened with Ramanujan. But you must listen to that inner voice. Don't do what the peers do. I don't know if you were born when the fire took place in this Upahar cinema. You know, hundreds of people died. You know, they didn't die because of the fire. They didn't die because of the smoke either. You know why they died? They died because of the stampede. All of them ran towards one exit when there were two other exits available. कोई नहीं गया उधर क्योंकि जो पहले दो तीन भागे जिस exit पे सब पीछे पीछे. This herd mentality, this worry about what the peers are doing, that destroys us. So don't do that. Listen to your inner calling and your dharma will rise and take you by the hand. Which is what happened with Ramanujan. He understood that his inner calling was mathematics. And you know, when you do that, all other attributes come to you. They come to you without fail. Ramanujan he was an excellent communicator. No one really remembers having taught him English. In fact, intermediate he kept failing in English literature. That is why they didn't give him the degree. But I have read all his letters that he has written in his own hand to G.H. Hardy. Marvelous compositions of literature. You look at that. Of course, he didn't want to memorize Shakespeare, but he was a great communicator. His use of the language is marvelous. Anyway, he was set on his journey, or school mein hi teachers ko itna to malum pad gaya. They understood that this is an extraordinary mind, that he is able to do things on his own that they can't even expect themselves to do. And as luck would have it, kuch nahi tha wahan par. There were no mathematicians, no books, no journals, no library. रामानुजन के हाथ में एक किताब लग गई called Carr's Synopsis of Mathematics. By today's standards, it is nothing but a mug book. Nothing but a mug book. But मैं यही कहता हूँ कि do not worry about your circumstances. हम क्रिप बहुत करते हैं. टीचर अच्छा नहीं था, वो खराब था, किताब नहीं मिली. कुछ नहीं था रामानुजन के पास. एक Carr's Synopsis, उसमें कुछ नहीं है. सिर्फ मैथमेटिकल फॉर्मूले लिखी है, ना प्रूफ है, ना कुछ है. उसी के आधार पर रामानुजन ने आसमान की हवा पकड़ ली. क्योंकि धर्म मिल गया था. जब धर्म मिल जाता है, उसको निष्ठा और धृति से लग जाते हो, तो वो तुम्हें उठा लेता है ऊपर. You evolve as a yogi, and he evolved. And everyone around him understood there's something extraordinary, but no one understood his mathematics. किसी के समझ में नहीं आया क्या कर रहे हैं. सब जानते थे कि जरूर रहा है, कुछ कर रहा है. He tried to talk to every single Indian mathematician alive. And there were many professional mathematicians, but they had no idea what he was doing. What a tragedy for this India, जहाँ calculus न्यूटन से 500 वर्ष पूर्व डिस्कवर हो गया था। Look at the tragedy, हम कैसे खत्म हो गए कि रामानुजन को कोई नहीं पहचान सका। Finally he started writing to mathematicians in England. वहां भी नहीं समझ रहे थे सब, until he wrote to G.H. Hardy. When he wrote to G.H. Hardy, Hardy of course was a great mathematician. I have the deepest respect for Hardy. And Hardy ने खुद ये कहानी लिखी है how he discovered Ramanujan. And no one discovered him. He was self-made, Swayambhu, self-made. But Hardy says that he received this letter one morning at Cambridge. After breakfast, he opened the letter, and there is this long letter. It starts, I am a clerk in the Port Trust of Madras. I beg to draw your attention because in my spare time I do mathematics and I have discovered some theorems which I want you to look at. That's all. This is that Ramanujan who by now knows that he is extraordinary. Ramanujan already knew he was extraordinary because the theorems he had discovered are so significant, and I'll tell you why I say this. Because when Ramanujan wrote to Hardy, he had already, as I said, discovered hundreds of theorems. But I'll tell you just one theorem that he discovered. It is called the prime number theorem. Let me tell you how important the prime number theorem is in mathematics. You know, in mathematics there is no Nobel Prize. But there is a prize which is called the equivalent of the Nobel Prize. It is even more difficult than the Nobel Prize. It's called the Fields Medal. Very difficult to get. You have to be below 40, it's given after every 4 years. Mathematicians are strange people. हम बड़े विचित्र प्राणी होते हैं। 4 साल में देंगे, 40 के नीचे होना चाहिए, उसके बाद कुछ भी कर लो नहीं मिलेगा। उसीलिए एक बहुत बड़े हिंदुस्तानी गणितज्ञ को नहीं मिला, हरिश्चंद्र को। 40 के बाद उन्होंने बड़े-बड़े आविष्कार किए जो रामानुजन के टक्कर के थे। लेकिन हरिश्चंद्र को हिंदुस्तान में किसी ने नहीं जाना, वो अमेरिका में मरे, जहां उनको नेशनल मेडल ऑफ साइंस मिला जो आइंस्टाइन को दिया गया। That's another thing. I don't want to talk about Harishchandra. Ramanujan, when he wrote to Hardy, had already discovered the prime number theorem. What is the prime number theorem? Well, prime numbers are very important in mathematics. Extremely important. Not just in mathematics. All the emails that you send, all the SMSs, all secret communications are encrypted using mathematical theories. All of them use prime numbers. That's how important they are. I know mathematicians who have become multi-millionaires by using mathematical knowledge about prime numbers that any schoolboy can use. And have combined it with IT and have marketed this software and have made millions of rupees. Prime numbers are really, really important. They are the building blocks of all of arithmetic. Even Ramanujan understood that. So he began to study prime numbers. And you know, he wanted to see how do they occur. What is the pattern for prime numbers? So he began to count prime numbers. Here is where his memory comes in handy. See, memory is so important. You must develop memory. So he had this prodigious memory and he could count the number of primes in the first 100 numbers, the first 1,000 numbers, the first million numbers. He could count the number of primes. He could compute them. And when he did that, he saw that this function that counts the number of primes up to the first n numbers, this function was following a certain pattern. Its graph looked like the graph of the function n upon natural log n. The graphs were similar. Now this in itself, as great mathematicians have said, is enough to make you be called a great mathematician. But Ramanujan didn't stop there. After having made this discovery empirically, he proved it as a mathematical theorem using mathematical logic. And why does this therefore make him one of the greatest mathematicians who have ever lived? For the following reason. That it took Europe 150 years of the last part of the 19th century and the early part of the 20th century to prove this same theorem. One mathematician building upon the work of the other and the other and the other. The greatest names, Gauss, Legendre, Lagrange, all of them. They built on the work of the previous, then Riemann came along and so on and so forth, and finally they proved it as a theorem. 40 years later, the proof of this theorem was simplified by Atlas Selberg at Princeton. And for this simplification of the proof, Selberg was given the Fields Medal. Now compare the achievement of Ramanujan. Sitting by himself, all alone in Kumbakonam. No mathematician to talk to, not anything from Europe, no journal, only writing on his slate and some scraps of paper. He not only discovered it, he proved it by himself. That is the genius Srinivasa Ramanujan that I talk about. But when he writes to Hardy, he knows he has discovered this, that it is a stunning discovery. But he doesn't once say, I have discovered great theorems. He just says, I beg to draw your attention. Look at the humility. You know, knowledge will only come to you when pride leaves. मैंने जितने भी बड़े लोगों को देखा है, विनम्र होते हैं. कबीर ने भी कहा है, जब मैं था तब हरि ना है. अब हरि है जब मैं ना है. Get rid of the ego. ईगो जाएगा तो नॉलेज के लिए जो तुम्हारा ईश्वर है, वो तब प्रयास करके अंदर प्रवेश करेगा. तभी you have to make room for that. That's what Ramanujan did. And Hardy, what is his greatness? He saw immediately that here was a genius writing to him. Immediately, you know, he says, मैंने वो चिट्ठी पढ़ी और मैंने वो फॉर्मूले देखे, वो theorems देखे. When I put it aside, I had to go play a game of tennis. Then I had lunch. Then I watched a cricket match. But all through the day, that letter kept hovering in my mind. It bothered me. Then he comes back and he looks at the letter again. And then he says that only two kinds of people can write such things. You have to be a crank or a genius. And no crank can write such sophisticated theorems. You have to have some logic in it. So this man must be a genius. And from that moment on, Hardy had only one motive, one ambition, one purpose. Get Ramanujan to Cambridge. अभी रामानुजन की दशा वहां इतनी बुरी है कि उसको खाने को ठीक से नहीं मिल रहा था. He was married. And all he wanted was कि कोई इतना दे दे कि खाने भर का मिल जाए. और कुछ नहीं चाहिए था रामानुजन को. साईं इतना दी कि वो जामे कुतुब समाए. That's all he wanted. So that I can pursue my dharma. But नहीं मिला था ठीक से. Finally Hardy ने बुलाया. Eventually Ramanujan went to Cambridge. It's another story and you must read all this up. I don't want to prolong this on and on. You must read the story of Ramanujan. There's a marvelous book. The Man Who Knew Infinity, Life of the Genius Srinivasa Ramanujan by Robert Kenning. You must read this book. All of you. There is so much to learn from this book. So much to learn from the life of Ramanujan. Went to Cambridge, he made other great discoveries. They're stupendous discoveries. You know, Ramanujan जैसे mathematicians एक हजार साल में भी नहीं आते हैं. एक हजार साल में भी नहीं आएंगे ऐसे mathematicians. I know mathematics, it is my profession. ऐसा करता है कि दिख जाए तो सिर लगा दें पैर में और वहीं रहें. इतनी ह्यूमिलिटी आ जाती है रामानुजन के बारे में सोच के, तब पता चलता है हम कहाँ हैं हम जो हम अपने को समझते हैं कि हम कुछ हैं. You have to understand his genius. But this man never once felt कि वो कोई बहुत बड़े आदमी. He was a simple man with simple tastes. सादा खाना खुद बना के खाते थे. Famous हो गए. The world began to recognize his genius. Ramanujan did change. Unfortunately, he fell ill at Cambridge. And Hardy realized he's going to die. He was very ill, seriously ill. So then Hardy sent him back to India. You know, Ramanujan was also an astrologer. I don't really advocate astrology much. There is something in it because Ramanujan, I have read an account by his wife, Janki. And she writes that Ramanujan told her and his mother that he made an astrological calculation and a prediction that he is going to die on this date, which was 1 year down the line. He knew he was going to die. He knew that his whole family was dependent on him. His entire family, father, mother, brother and wife. There was no source of income. And the British government, because now he was a great scholar, had now sanctioned a huge salary. But there is a letter on record. Ramanujan writes to the government and says, I do not need this. Let this money be put aside for talented and needy students of India. That is what I said at the beginning. He understood how to make society work. Samaj ka rid chukaya Ramanujan. This great son of Mother India stood up to the needs of his nation. और यहीं पर कहानी नहीं खत्म होती रामानुजन की. You must understand you are indebted to Ramanujan. आज यहाँ पर अगर आपको साइंस और टेक्नोलॉजी मिल रही है तो वो रामानुजन की वजह से है. क्यों? रामानुजन के बाद भारतवर्ष फिर से जगा साइंस में, फिर से हमारे अंदर आत्मविश्वास पैदा हुआ कि हम कर सकते हैं. गोरे के सामने हम उसको नीचा भी कर सकते हैं. भारत फिर खड़ा हुआ. चंद्रशेखर वेंकट रमन आए, चंद्रशेखर सुब्रमण्यम आए, जगदीश बोस आए, एस.एन. बोस आए. They were all people, Meghnad Saha, people who did Nobel Prize winning work because they regained the self-confidence that we could do this. That and all of them have recorded कि हमें आत्मविश्वास इसलिए मिला कि रामानुजन ने गोरे के सामने खड़ा होकर दिखा दिया. If you read the autobiography of Subramaniam Chandrasekhar, who won the Nobel Prize in physics, he writes that when the students, India was under the foreign yoke, गुलामी के शिकंजे में जकड़ा हुआ था, मनोबल देश का टूट गया. He says there were only 4 names that inspired us: महात्मा गांधी, रविंद्रनाथ ठाकुर, जवाहरलाल नेहरू and Srinivasa Ramanujan. यही 4 थे जो युवक को इंस्पायर करते. That is the debt you owe to Ramanujan. समाज का यही ऋण है. इसी से भारत फिर से साइंस में आगे बढ़ रहा है. If today we are one of 3 countries that has the capability to put a man on the moon, 3 ही देश हैं सारे विश्व में who can have the capacity to put a man on the moon. India is one of them. To a large measure, it is because Ramanujan awoke the genius in Indian science, and you are indebted for that. Do not forget that, and discharge your debts to society, as all the great sons of India have done in the past. Not just Ramanujan, even Bhagat Singh did that. When Bhagat Singh was condemned to die, his father said that I have proof to prove his innocence, and Bhagat Singh immediately countered his father through a public review published in a paper. He says, I don't want that proof. And then his friends in prison asked him, Rajguru Sukhdev, they all asked him, Bhagat, तुम जीना नहीं चाहते? He says, कौन नहीं जीना चाहता? जीने की इच्छा प्रबल है मेरे अंदर, मगर उससे भी कहीं ज्यादा प्रबल है इच्छा देश को आजाद करने की. इसलिए मैं ये उदाहरण देना चाहता हूँ. समाज का इसी तरह ऋण चुकाते हैं. Remember that you belong to that tradition. I finish my talk. Thank you very much.